Welcome to BitPeeps Radio. We are on day 2 of learning Bitcoin from scratch, starting with the fundamentals in Python. So yesterday we covered a basic introduction to what is Python. We did variables. We discussed the different types of variables like numbers and strings. We even did some coding and we went into lists. So today we're going to be carrying on with the basics of Python so that we can learn how to code a Bitcoin library and understand the tech and what's actually going on under the hood with Bitcoin. I just wanted to share with you guys before we dive in that I have actually requested from BSV a copy of this ebook, which is Innovating Justice. And this book is basically going to cover the revolutionary impact of blockchain technology on law enforcement. And it basically teaches you about the unparalleled security, transparency, and scalability of the BSV blockchain projects and how that protects our rights by providing law enforcement professionals with the tools for greater efficiency. So definitely stay tuned for that. I have requested the ebook and I will be covering it in the future. I'm going to switch over now to our screen so we can carry on with some coding in Python. Alrighty. Oh, and I've also got my notepad today. So I'll actually be sharing with you guys notes as we go along. I think that will be quite useful. And we will also have some music breaks in between. It's actually quite important when we're learning new things. Always when I study personally, I work on about 45 to 50 minutes of solid studying and learning. And then I have about a 10-minute break. You'll actually find like that, you can go on literally for hours studying just by giving yourself that break. So I'm looking forward to some short music breaks today. I will put in some timestamps if you want to skip those. But like I say, it does help, especially if you're coding along with me, just to take that little break in between. So today we're going to be looking at basic operators. So operators are like, if you think of maths, they're like your pluses, your minuses, how to multiply, divide, and use exponents. Remember, we are going to, on this channel, we are going to be covering quite a bit of maths. Once we've covered the fundamentals of Python, we're going to have to know some maths so that we can understand elliptic curves, which is related to Bitcoin. Just as any other programming languages, the addition, subtraction, multiplication, and division operators can be used with numbers. So remember, it applies to numbers, not strings. So here, they've created a variable called number. Number equals 1 plus 2 times 3 divided by 4.0. Remember that 4.0 from what we covered yesterday is an integer, so it's got a decimal, and we learned how to, there's two ways to use decimals in Python. The one is just like they've done here by putting in the 4.0, or you put in float and then in brackets 4.0. So if we print number, we should get the answer 2,5. So I'm assuming that it's, okay, I was going to say order of operations. Try to predict what the answer will be. Does Python follow order of operations? So remember, for those of you that don't know, we if you follow this from left to right, you're going to get a different answer than if you use order of operations, which is basically how I remember it, BODMAS. So you do the brackets first, then the multiplication, and you go on like that. So the addition and the subtraction only happens last, and that's how you get to the correct answer. Another operator available is the modulo percent operator, which returns the integer remainder of the division. So let's just check first. I wonder if I've got a calculator here. Did it actually follow order of operation? So we should start with 2 times 3. 2 times 3. And then we say divided by 4. So our answer is 1,5 for this section to the right. So if we get 1 plus 1,5, we get 2,5. So basically, Python does follow order of operations. Let's try it without order of operations. 1 plus 2 times 3 divided by 4. So my calculator is automatically using order of operations. So if I say 1 plus 2 is 3, right? If we say 3 times 3, that would be 9. And if we say 9 divided by 4, yeah, we get 2,25. So there is a slight difference. Instead of being 2,5, the answer is 2,25. So that's why our order of operations is important. But the good news is we don't have to actually know it because Python does it automatically for us. So now let's look at the modulo operator, which is the percent operator, which returns the integer remainder of the division. So remainder equals 11 percentage 3. So I'm assuming we're trying to say 11 divided by 3. If I do that on my calculator quickly, we get 3,66666 and so on. So it should give us the 666. So I'm just running the code, giving us 2, which returns the integer remainder of the division. Integer remainder of the division. It's giving us the answer 2. So let's ask ChatGPT. To me, it's the answer 2 in this Python code. Python, the modulo operator, so it's basically the percentage symbol, is used to find the remainder when one number is divided by another. Here's a step-by-step explanation of how the code remainder 11% 3 gives the result 2. Modulo operation. The expression 11% 3 calculates the remainder when 11 is divided by 3. To understand the modulo operation, we first perform the division of 11 by 3. 11 divided by 3 equals 3 with a remainder of 2. 3 times 3 is 9, and 11 minus 9 equals 2. Okay, remainder. The remainder is what's left after subtracting the largest multiple of the divisor, which is 3. That is less than or equal to the dividend, which is 11. In this case, 9 is the largest multiple of 3 less 11. Thus, the remainder when 11 is divided by 3 is 2. Therefore, when you execute the code remainder equals 11% 3, the value assigned to remainder is 2. The print remainder statement then outputs this value. So do we understand it? So we're trying to say 11 divided by 3. 3, 6, 9. It can only go 3 times. So our answer with it can only go 3 times fully into 11. The answer is 9. And then all we do is we say 11 minus 9, and that remainder is 2. Okay, that makes sense. Using two multiplication symbols makes a power relationship. So if we run this code, so our variable is squared, so it's 7 to the power of 2 cubed, 2 to the power of 3. Let's run that. Yeah, so let me just clear here. Oh, okay, I understand. So it's cubed because if we, let me just write it down because I think it will make more sense. I'm going to switch over here if I can just show you. Okay, so basically they've said they've created a variable called squared. So that's our variable. Remember, we're working on numbers. So the value is going to be a number, or the type of variable is number. And we are saying in this question, seven star star 2. So remember, 1 star would be multiplication. When we use 2 stars, then it means from a mathematical perspective, we would write it like this, 7 to the power of 2, which is basically 7 times 7, which is 49. So we don't only get to the power of 2, we can do it to the power of 3. So, and that's what we call cubed. So they created a new variable now called cubed, and they are working on 2 to the power of 3, which is basically looks like this, 2, 3. So we would say 2 times 2 times 2, basically. And we get our answer, which is 8. Because 2 times 2 is 4, and if we times 2 again, if we times 4 by 2, we get 8. So that's how we can create exponents using Python. So it's 2 multiplication signs or 2 stars. Using operators with strings. So remember, we've worked with 2 types of variables, numbers and strings. They've shown us how to use operators like plus, times, divide, which is the forward bracket, using numbers. Now we're going to see how it works with strings. Python supports concatenating strings using the addition operator. So concatenating strings basically means when you can take 2 strings from 2 different variables. In this case, they haven't divided it into two variables. They put it as one, and you basically concatenate it. So you join it to make it into one, or to make it into one sentence. So we did a little bit of this yesterday. So if I run this code, we get hello world. In the example that we did yesterday, you can see here we've got our string hello. We concatenate strings using the plus sign. So, I mean, that makes logical sense. You're adding the words together. And then we have here two inverted commas with a space in between. And we were wondering why that looks odd. Why do we need that? Because if we remove that and we just say hello plus world, we're going to end up with one word instead of a space between the two words. So if I print it now, do you see there that we've got it as hello world without a space in between? So I'm just going to put it back and add our plus sign, and it should work. Python also, excuse me, Python also supports multiplying strings to form a string with a repeating sequence. So this is new to me, but it looks like to me it would basically print hello 10 times. So the variable is lots of hellos equals, and then we've got the hello string times 10. So let's see what happens when we print lots of hellos. And there we go. It's printed it 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it's done it 10 times. There's no spaces in between. So probably at a later date, we'll learn how to work around that. But it's printed the word 10 times. So we can, here we can print it by 20. And you can see now we have a lot of hellos. Okay, using operators with lists. So remember we worked with lists. So when we create a list, we use the square bracket. Even numbers equals, and then we've made our list. We separated each element in the list with a comma. Remember when we're working with lists, unlike arrays, we can have a combination of numbers and strings. So they've created two lists here. We've got even numbers. Notice there the underscore between the two words, and it's all lowercase. So we need to keep that in mind when writing code in Python. And then we've got our odd number list, which is 1, 3, 5, and 7. Then we've created a variable where we are joining the two lists, and we are saying all numbers, so that's our variable, and then we're saying odd numbers. So we're taking our list here, plus even numbers. So we're using the function, or sorry, the operator, the plus sign, to add the two lists together. Let's see what we get. It's given us a new list, odd numbers plus even. Okay, see what it's done here? So it hasn't done the numbers like from descending to ascending, or from smallest to biggest. It has printed our odd numbers first. So all our odd numbers in our odd numbers list, 1, 3, 5, 7 is first. And then it's done all our even numbers, 2, 4, 6, 8. Just as in strings, Python supports forming new lists when you're repeating with a repeating sequence using the multiplication operator. That sounds a little bit confusing. Okay, so we've got your print. We've got our square brackets, which indicates a list, 1, 2, 3, and then we're saying times it by 3. Let's see what happens. Okay, so what it's done is like here where we printed lots of hellos. So we put in the string hello, and then we said times 20. It was originally times 10. Now we've got our list 1, 2, 3, and we're saying basically repeat it 3 times. So 1, 2, 3, 1, 2, 3, 1, 2, 3. That's simple enough. So let's move on to our exercise. The target of this exercise is to create 2 lists called X list and Y list, which contain 10 instances of the variables X and Y, respectively. You are also required to create a list called Big List, which contains the variables X and Y 10 times each by concatenating the 2 lists you have created. So I like to break it down. Whenever you get a question like this, where there's a few things we have to do. So first we've got to create our X list and our Y list. So I'm going to code it here, even though it's there already. X underscore list equals, and then Y underscore X. So we've created our 2 lists, or at least the name, which contain 10 instances of the variables X and Y. So here in our X list, we're going to put, remember it's a list, so we're using square brackets, X, and square bracket for our Y list, Y. Okay. You are also required to create a big list. Big list equals, and then remember, I see what they've done here. They've put it empty, so we're not assigning variables to it yet. You are required to create a list called big list, which contains the variables X, Y, 10 times each. Print. X list contains the objects and almost a I don't know. These exercises are a little bit annoying because they try and do anything, other things. Like now they're adding an if statement, and if we get a certain result, it's going to tell us almost there or great. But that's not what the question's asking us to do. So I will get some clarity from ChatGPT. But before we do that, let's actually do a question. So we have to, it has to contain 10 instances of the variable. So I'm thinking we need to take that and multiply it by 10. So the way we did that, if we go up, right, so we would use print. X. Do you think we can do this? I don't know. If we say times 10, I wonder if it's going to give us an error. Because if I use the print, we're not really iterating it, if that makes sense. It's just giving us that as an answer. But within the print only gives you the output. I want it to be, my understanding of the question is that within the variable or within the list, it needs to be iterated, or it needs to be repeated 10 times. It says create 2 lists which contain 10 instances. So it has to be in here, not afterwards in a print function. So now, a good way when you're coding to see if you're going to get an error or anything like that is to use the print function. So we're going to print x list, and we're going to print y list, and we're going to see if we get delete this. We'll just refresh the page if we want to. So let's I know it's going to tell me I'm wrong. Nope. Object add didn't work. Let me delete the objects. Another thing that I know from JavaScript is like, because you see it's referring to objects, and we had that object at the top. When it gives you errors, it's not going to give you all the errors. It's going to give you the first error that pops up. So I've deleted that to see what happens. File script, error name, X is not defined. Yeah, I know it's not defined. I just want to repeat it 10 times. X is not defined because it's... What if I add it as a string? I think what it's telling us is we haven't defined X. It's not getting to Y yet, but it's going to give us the same problem. We haven't defined X as a number, so it doesn't know, it's not recognizing it as a number. So we need to make it a string. Let's see. I went to the solution. Go back. I'm so annoyed now. Basic operators. That object was giving us the error, so we got rid of that error. Remember, the hashtag is for comments. So we are going to try and do it as a string. X times 10 y 10. And we're going to print X list, and we're going to print y. My stream health seems to be good. Why is the internet so slow? File script. Line 2 y list. Invalid syntax. Oh, yeah. Okay. Always read your errors, okay? That's how you learn. I forgot my... Okay, so create two lists called X list and Y list, which contain 10 instances of the variables X and Y. You are also required to create a big list, which contains the variables X and Y 10 times each, by concatenating the two lists you have created. So the big list is fairly straightforward. Remember, when we concatenate, we use the plus. So we're going to say X list plus Y list. And it's given us our, oh, I didn't print. So it just repeated these two lines of code here. I basically repeated that. So now we're going to print big list. You see, now we get our full answer. Remember here we were printing the X list, then we printed the Y list. Now it has in one list put in our X's and our Y's 10 times. I know this is not ideal because the X is supposed to be a variable and the Y in itself is supposed to be a variable, meaning that we have to be able to assign variables. It's not X in the literal sense. So it could be any number that's later assigned to X or Y. However, when I tried without like reverting it to just an X like that and a Y like that without the apostrophes, remember it gave us that error because it's saying that X and Y are not defined. You see here, X is not defined. What if we say X equals Y equals? I know how to do it in JavaScript. You see, invalid syntax. If we assign 5 to X and 2 to Y, then you'll see it'll put 2 10 times for the Y list and 5 10 times for the X list. Oh, so it works. The idea works. The target of this exercise is to create two lists called X list and Y list, which contain 10 instances of the variables X and Y. So we've created 10 instances of 5. We've created 10 instances of Y, 10 times each, by concatenating the two lists you have created. So we've done that. I'm quite happy that we understand the question. Now the question is, what other code were they adding here? I see we got disconnected. Yeah, I hope the connection's better now. So now we're going to look, now that we've identified how to answer the question, I want to see what, because they've added code here that we don't really know yet how to do. And we're going to try and analyze it. X equals objects, square, round brackets. So I think this is for, at this stage, we don't want to assign a value to it yet. Change this code. X list equals X. So it's a value or an object without any number assigned to it yet, and the same with Y, Y list. Big list is currently empty, but I can probably say X list plus Y list. Print. X list contains percentage D objects. Yeah, I don't know what they're doing here, honestly. Print Y list, and then they repeated that. think len is the length of the list. And it looks like we're using our, what is it? Our modulo operator. So remember how that worked. So we're going to get the answers. Where is it? Modulo. Yeah, it is the modulo operator because I'm seeing a lot of percentages here. So we're going to work out that the X list contains so many objects. Divided by, or to calculate the remainder based on the length of the X list. The same with Y. Print big lists contains something objects, percentage of the length of big list. Testing code. If X list count X is equal to 10 and Y list is equal to 10, that will be true if we've done the code correctly. Somewhere we need to multiply it here by 10, like I did. Then print almost there. If big list count is equal to 10 and big list count Y is equal to 10, print great. It won't ever be great because big list is going to contain X list plus the Y list, and that would be 20. I just want to see here if I try what I did and say times by 10 times by 10. You see what happens? It worked. X list contains 10 objects. Y list contains 10 objects. Big list contains 1. Why does the big list contain 1 object? So I just want to make a note here. When we are creating a variable, but we don't want to assign a value to it yet, it looks like, or we just want it to be like an object, but without a specific value, then we use this object. You see here it's in red. So y equals object and then empty brackets. And then you see the code work. There was no errors. So before, when I did this and I was getting an error because I didn't assign a value, or I turned it into a string to print x times, or I had to say let x 5, it prevents that error from happening. So all you do is you keep your x and your y, which is based on these two variables here, which are only assigned an object value, and then in brackets, you times it by 10. But remember to keep the x and the y in the square brackets. Then there's other code here, which it's basically this print is printing this string. X list contains 10 objects, which is correct because we've times it by 10. Did I get the answer right? Oh well. And then we've got print Y list contains 10 objects, and then big list contains 1 object. Almost there. We need, I think the answer is that we needed to get to 20. The big list needs to be 20. Big list count x is equal to 10 and big list count y is equal to 10. Why does big list contain one object. Do you think it's because I put in the round brackets? I wonder what will happen if I take out these round brackets. It still contains one. So let's try square brackets. Because it's, I don't know, an object and an object. Limit. Big list still only contains one object. What if we say x times 10, just like that? Maybe I'm complicating it for no reason. I just don't feel that that's right though. X times. It's giving us an error. So our problem now is that for whatever reason, our big list is saying we only have one object. So there's a problem in the way that we have done this. So I'm just going to add the round brackets back because it seemed to be working. And I'm going to separate it. Maybe now it'll tell me we have two lists, two objects. Big list contains two objects. You are also required to create a big list which contains the variables x and y 10 times each by concatenating the two lists you have created. If I say print x list and I say print y list, submit. If you don't understand enough about objects yet, what if I use round brackets, not square bracket, submit. Did you correctly define running the len big list didn't generate? Did we do it? Now we've got big list contains 20 objects. Almost there. We're getting it, guys. So I've managed to do it so that I'm using the word iterate. It has 10 instances or 10 objects of x, 10 objects of y. By using round brackets, not square brackets, we now have 20 objects in our big list, which is correct. It's giving us two results though. It's printing almost there and great. How can it do that? It's an if statement. If x, yeah, if x list is equal to 10, y list is equal to 10, print almost there. That's good. If big list count is equal to 10 and big list count y is equal to 10, big list print great. Let's see what the solution is. Solution. X times 10. Okay, so we didn't need the brackets like I had it. You can just say times 10. X list plus y list. Yeah. Print. Submit. Work. Guys, I think I did it because it's printed the script. Whoops. Twice. I just don't understand. They've said X list plus Y list. How they're getting. Anyway, okay. Just want to see because if need be, I will ask ChatGPT. Submit. Yeah, I think the point is that we managed to get X is 10 and we managed to get Y is 10 and we managed to get big list is 20. I'm not sure how long we've been streaming now. Just see here. So we are now on string formatting. Great, so we're actually going to learn now how to remember how to concatenate strings without having to account for silly spaces. I want to just do perhaps a recap or a quick summary, and then we'll have our music break. So let me switch us over to my noteboard. And then I'm going to just create a new. So let's quickly do a summary of our operators. So we have our arithmetic operators, which are our pluses, and we use that to concatenate strings. Obviously, to add numbers, if you want to do that, like as a calculator, minus. We learned times, which is a star. We learned that 2 stars is to, for example, create a power like 2 squared, or even to create a cube like 3 cubed, so 3 times 3 times 3, and so on. So you can really go to up to any number you want. We learned divide. Remember, that was in our first example. We learned that Python does our order of operations for us. So we don't have to worry about brackets and that sort of thing. And we learned about what is the modulo, which is this percentage sign here. So if we say, for example, 11% 3, it's going to give us a what they call a remainder. So how many whole times can 3 go into 11? It would be 9. And then we just say 11 minus 9, and our answer is going to be 2. So this percentage operator basically works that out for us. Did I switch over? Yeah, I did. Okay. So let me just see here. So we learned how to make a power relationship. We learned how to concatenate strings using the plus. So if we say our string here, hello, and then we can keep on adding other words. But remember, we're going to have to factor in spaces at this stage. So we put in a blank space, and we can say, for example, Bitcoin. And then when we actually use our print, it will say, hello, with a space, Bitcoin. So I just want to clear this. If you want to take a screenshot of this, you can. Let me open up a new one. Menu here. So we also learned that we can repeat a string, for example, hello, or like in my case, X. We can repeat it 10 times just by multiplying it by 10. And then it will print X, 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 X 10 times. And basically the same logic applies when concatenating strings or adding numbers to lists. So we can combine two lists. So remember, our lists are the square brackets, and however we choose to define that, we can join them into one big list. Just as in strings, Python supports forming new lists with a repeating sequence using the multiplication operator. So if we want to create a new list, that's actually what I was trying to do when we got stuck on that question with X. So if we say, let's call it random variable, and our list was initially, let's say, 3, we can create a new list by, timesing it by whatever number we like. And I think that's about it for this recap. We'll be taking a short music break, about 10 minutes, and I'll see you guys shortly, where we will go into a bit more depth now on strengths. We are back. I hope you enjoyed that little break. I do apologize if there is some buffering happening. So let's further ado resume. I see it's still buffering. Okay, I think we can next tutorial with our learning. Right. String formatting. Python uses C-style string formatting to create new formatted strings. The percentage operator is used to format a set of variables enclosed in a tuple, a fixed size list, together with a formal string, with a format string, which contains normal text together with argument specifiers, special symbols like %s and %d. So that's what we saw actually in our previous exercise. I remember the %d. This prints out hello John. Name equals John. Prints hello %s %name. So I wonder what is the %. So I'm going to use ChatGPT. Can you explain to me the %s and the %d? In Python, the percentage operator is used for C-style string formatting, which allows, whoopsie, where are we? Which allows you to insert values into a string at specified locations. This method involves the use of format specifiers such as %s and %d within a format string. Here's a detailed explanation of how they work. %s. This specifier is used to format strings. When you use %s in a format string, it will be replaced by the string representation of the corresponding variable. So I think our corresponding variable is %name. Remember, our name here is John. So we're filling, instead of saying print hello and then typing in John manually, we're saying %s. There's an exclamation mark because it's part of the string. If you look here, close inverted commas, and then the percentage represents the name. %d. This specifier is used to format integers. So remember, integers are numbers but with a decimal. When you use %d in a format string, it will be replaced by the integer value of the corresponding variable. So I think that applies to numbers. To use these format specifiers, you place them in the format string where you want the variable name values to be inserted. Then you use the percentage operator followed by a tuple containing the variables. So here's an example. Name equals Alice. Age equals 30. Formatted string equals my name is %s and I am %d years old. And then after our string, because that's in inverted commas, we define the percentage. So we have name and then we have age. And then we say print formatted string. So formatted string is the variable. %s is the placeholder. %d is the placeholder for the integer age. Tuple of variables. Name is Alice, age is 30. So it looks like this is the tuple. %s is replaced by Alice, %d is replaced by 30. Result. The formatted string becomes my name is Alice and I am 30 years old. When you run the code, it prints my name is Alice and I am 30 years old. You can also use multiple variables and format specifiers in a single string. So now we've created 2 numbers and 2 strings. So first name is Bob, last name is Smith, age is 25, height is 175.5. So now we say formatted string equals name, %s, age, %d height, percentage, and we say dot if centimeters, dot, and then if centimeters. And then after our string, we put percent, and then so this is called a tuple. First name, and it looks like it does it in order. First name, last name, age, height. And then we print formatted string. So %s replaced by first name and last name, %d replaced by age, %.1f, oh, is that a 1? Formats height as a floating point number with 1 decimal place. Output, Bob Smith, age 25, height, and output. So we're going to say, actually I'll use this and I'll say Christina, and then we'll say age equals 31. Then we're going to create a variable and we're going to say about underscore me equals, whoops, so I see my camera is a little bit off there. Still having problems. Still buffering. Oh, that's really annoying. So about me. Now I'm going to create a string. So my name is, then we use %s, and I am %d years old. And then what we do here is we say percentage and we create a tuple. And we're going to insert our 2 variables that we created, name and then age. Remember, we do it in order. So now if we say print about me, and we say run, my name is Christina and I'm 31 years old. That's simple enough. So I just want to clarify the percentage is so the percentage is for strings and the percentage D is for integers. So now we can make it a little bit more complicated, just like we did in that example there. Christina, or let me try pseudonym equal Taylor, and favorite underscore number equals 369.3. So now we can say, I think I'm going to try doing it without looking. We're going to say percentage S, so that it says Christina, aka Taylor, and I am, that's fine. My favorite number is percentage D, and then they said 1F. So it looks like if I say 36, we're going to format it to one decimal place. That's hard. So it looks like we just say .f because it formats this percentage .1f formats height as a floating point number. Remember in our first video, we learned about the float, and then you put the decimal in the brackets next to it. And we're doing it with one decimal place. We'll try with two. So now I'm going to say name in my, what do they call it? Tuple? Age, and then, this cat. I think he wants to go out. Favorite number. Print about me. Error. Pseudonym is not defined. I did define it. Let's say AKA. Run. My name is Christina, aka Taylor, and I am 31 years old. My favorite number is 36.9. Oh, so we forgot the 1. So if I put 1 before the F, so it's actually rounded it up. So the .1F basically rounds it up a decimal place. If we say here 2, it should give us 2 decimal places. It has. And now I want to try without that formatting. So just say percentage D. Is it going to give me an error? No. Okie dokie. I get it now. My name is Christina, aka Taylor, and I'm 31 years old. My favorite number is 369. So it doesn't recognize it as an integer without that .f. If I just say .f without a number, nope. So it looks like we have to put in 2f. Let's just try, because I still had the D there. Yeah. So if you wanted to recognize it as a decimal, then we have to, I was wondering if we could put in the float. That doesn't seem to work. Because how would you know? Like, let's say you don't want to round it off at all. How would you know how many decimal places you could end up with? So there must be a way using that method of float. What if I put dot float at the end? Ah, okay, I'm getting some weird answers here. So I'll just keep it dot to end for now. So now we know the percentage S is for string and the percentage D is for number. So now if we try this example now should be fairly simple. Hello, and then percentage S, exclamation mark, and then over here we put in our percentage and we say we are printing. It should work. Hello, John. Perfect. To use two or more argument specifiers, use a tuple. So we've done that. So it will give us a name, which is John. John is 23, that's the percentage D, years old. John is 23 years old. Any object which is not a string can be formatted using the percentage S operator as well. The string which returns from the REPR method of that object is formatted as the string. For example, we've created here a list, my list, and its numbers 1, 2, 3. So those are numbers, not. So now we've said print a list. So that's a string, and then we say percentage S. So we haven't used percentage D, which is what we normally do for numbers. Then we've closed the string and we said percentage, and then the tuple is we're calling in all the items contained in the variable my list. So let's run it. Come on. A list 1, 2, 3. Should we try on our own? So we're going to say print. We're going to print a string. We're going to say my list is, we're going to say percentage S. And then outside the string, we're going to define it using the tuple my list. And we should get the same result. my list is 1, 2, 3. Here are some basic argument specifiers you should know. Percentage S for string, or any object with a string representation, like numbers. Percentage D is for integers, so that is for whole numbers. Percentage F is for floating point numbers. I wonder, oh, I deleted it. Okay, it's fine. Put here 23.5, and I say percentage F, 569. I know that doesn't make sense. Let's see if we can run it. So if we say 569 and we instead of percentage D, we say percentage F, remember I was having that problem where it wouldn't return all the decimals unless I specified it. So I think that solves that problem. Yeah. So it's actually added all the decimals. So if you don't want to be specific about how many decimal places, you just use percentage F. But here we can maybe say 2 decimal places. I think we have to say dot 2F. And then it should actually round up to 23.57. Perfect. I get it. Then we've got percentage, and then we've got dot, number of digits F. Numbers with a fixed amount of digits to the right of the dots. So that's interesting because you notice here when I just said percentage F, it added 0. See here, it said 23.5690000. So it looks like if we say here next to the percentage, if we add in dot number of digits F, so we say percentage and then now it should run it without giving us all those extra zeros. Unsupported format character at index 8. So what did I do wrong? I think you have to put in a number. Calculator. Let's try 1. I think you don't, it's what I've already done, where you just put a number. Okay. And then the last one, percentage X / percentage uppercase X. Integers in hex representation. Lowercase stroke uppercase. Done that? So ChatGPT, I'm learning string formatting in Python. Can you explain this? argument specifier string. And then I lose my place. In Python, the percentage lowercase x and percentage high uppercase x format specifiers are used to convert an integer to its hexadecimal base 16 representation. The difference between the lowercase and the uppercase percentage x is in the case of the letters used in the hexadecimal representation. So the percentage lowercase x converts an integer to a hexadecimal string using lowercase letters A to F. Percentage uppercase x converts an integer to a hexadecimal string. Hexadecimal hex is a base 16 number system. It uses the digits 0 to 9 to represent values 0 to 9 and the letters A to F to represent values 10 to 15. So A to F is 6 letters, and we've got 0 to 9. That would be 9, so that gives us 15 usage. To use percentage x in a format string, you place it within the string where you want the hexadecimal value to appear and follow it with the percentage operator and the integer you want to convert. Here are some examples to illustrate how percentage x works. So now we're using the lowercase percentage x. We have the number 250. Formatted string. The number percentage d in hexadecimal is percentage x, and then you put your percent, and then you put number. I wonder why they put number twice. In the bracket. Explanation. Percentage d formats the integer number as a decimal, a base 10 number. Percentage x formats the integer, the number, as a hexadecimal base 16 number using lowercase letters. The number 255 in hexadecimal is FF. And if we do it now with the percentage in the uppercase x, we get where it was FF in lowercase, it now becomes FF in uppercase. And then, of course, we can do it with multiple numbers. So as long as you define them in your tuple, you can really put as many as you want. Summary. Percentage x converts an integer to a lowercase hexadecimal string, and percentage uppercase x converts an integer to an uppercase hexadecimal string. Using these format specifiers allows you to represent integers in their hexadecimal form, which can be useful in various applications like debugging, working with memory addresses, or dealing with binary data. I feel like this is going to be important for Bitcoin, but let's test ChatGPT. Does the code for Bitcoin use integers in hexadecimal form, how, why, and to what extent. Ooh, okay. This is very important, guys. So I hope you're paying attention. We're not learning Python just for the sake of it. We're learning Python for programming Bitcoin. So this is very important now that we understand these representing integers as a hexadecimal. Okay, so listen up. Bitcoin, and more broadly, blockchain technology, makes extensive use of hexadecimal representations for several reasons, primarily for readability, compactness, and standardization. Here's an overview of how, why, and to what extent Bitcoin uses hexadecimal integers. How all the points, and then we'll read them all. So 1 is for addresses. 2 is for transaction IDs. 3 is for block hashes. 4, script and smart contracts. So starting with addresses. Bitcoin addresses, while usually represented in base 58 or BEC32 formats for human readability, internally involve hexadecimal data. For instance, the public key, which is part of the address generation process, is often represented in hexadecimal. Transaction IDs. Each Bitcoin transaction is identified by a unique transaction ID, which is a hash of the transaction data. This hash is typically represented called a block hash. This hash is also represented in hexadecimal. Script and smart contracts. Bitcoin scripting language used in transactions often involves hexadecimal representations, especially when dealing with raw script data or signatures. Cryptographic keys. Private keys, I left that one out, my apologies. Private keys and public keys are often displayed and stored in hexadecimal formats. This is standard practice in cryptography because hexadecimal is a compact and readable way to represent binary data. Why Bitcoin uses hexadecimal? There are 4 reasons. 1 is readability. 2 is compactness. 3 is standardization. And 4 is efficient debugging and development. 1. Readability. Hexadecimal representation is more human readable than binary. So binary, if I'm not mistaken, is like literally one. It is easier to read and write than long binary strings, while still being closer to the underlying binary data than decimal. 2. Compactness. Hexadecimal representation is more compact than binary. It uses 4 bits per digit, which makes it and less prone to error when manually inspected or entered. 3 is standardization. Hexadecimal is widely used in computing and cryptography. This makes it a standard way to represent data, ensuring consistency and compatibility across different systems and platforms. 4. Efficient debugging and development. Developers and cryptographers are accustomed to working with hexadecimal. This makes debugging, development, and verification processes more efficient. Extent of hexadecimal use. Hexadecimal representation permeates many aspects of Bitcoin's protocol and implementation. Here are some specific examples. So the examples we've got here are private keys, often represented as 256-bit numbers in hexadecimal. We've got public keys, represented as a 65-byte hexadecimal string when uncompressed. Transaction hashes and block hashes. Both of those are 64 hexadecimal characters. So we've got a practical example of a transaction. We've got our TXID, which is our transaction hash, and then we've got our hash. I think that's the block hash. And they are displayed in hexadecimal. Then we've got a block example. So of my very basic understanding of Bitcoin, it's each block, yeah, there's a hash or code that follows from block to block. So we've got our hash and we've got our previous block hash, which are in hexadecimal. Hexadecimal representation in Bitcoin is fundamental for various aspects of its protocol. It offers a balance between human readability and data compactness, which for handling cryptographic keys, hashes, and scripts efficiently. By using hexadecimal, Bitcoin ensures that it adheres to industry standards and maintains compatibility across different systems and platforms. Probably what they mean here, I don't know, when they say about compatibility, is this is quite close to binary language, which is that's like deep computer programming. It's like the base level, and this is the step up. So it's really like when you get to programs like JavaScript and Python, those are more higher level languages. So because it's coming, the hexadecimal is from such a low level, like every computer uses, I don't know if I'm using the right jargon here, uses like low basic computer programming. It doesn't matter if you're using a Mac or any other, or Windows, right? Okay, we lost disconnection there. Got disconnected. I'm so excited because I feel like we've really found a gem. Like I say, the reason we are learning Python is not because I'm super bored and I've got nothing better to do. The goal is Bitcoin. And already in learning the basics, we've discovered something very fundamental and foundational to Bitcoin, which is hexadecimals. So I think I'm going to do this exercise, but now it's very important, keeping our goal in mind, that we do actually focus a lot more on this. So I'm going to definitely, we will do another live this afternoon, and we will focus purely on hexadecimals. I'd like to just do some preparation first and get some resources together. For now, we're going to go straight to the exercise. Exercise. You will need to write the format string, which prints out the data using the following syntax. Hello, John Doe. Your current balance is $53.44. So we've got a variable here called ATA, which equals John Doe 53,44. And then we've got format string equals hello. So we are going to Percentage, why does it have data at the end? Isn't this more like a list? So I feel like it should be square brackets. I don't know why it's called ATA. We print. I feel like this is a difficult example. Because from our I wonder, I say submit, will it just print hello as a string? It says, did you correctly define the variable format string? So we're actually going to create our string here and then we're going to print it. One thing I learned, which is through my course with Jonas Schmidtman on JavaScript, is that there's no one way to get the results. What or programmers, we're just looking to understand how it works and how to read the code and what these different things mean. I mean, in our previous exercise, we saw the percentage S and the percentage D, and it was very confusing, but gibberish. So what matters is that we get to our answer at the end. Like I said, there's no really right or wrong if you get the right end result. So one of the things that I enjoy about coding is like the problem solving skills. Like it's giving me the answer, which I don't want. So we're going to say hello, percentage is. Over here, I'm going to already start. So I've changed it. I've changed it to a list. So let's see how well I can remember. We're going to say eta brackets 1 because we're calling on the first element of the list. Then we're going to say eta brackets 2. Oh, little, I forgot. It's 0 and 1. How could I forget that? Seriously. Okay. Hello, John Doe. Your current balance is percentage dot will it work if I say percentage F? I forgot now. Percentage F. Then in brackets here we'll just say eta 2. Do you think it's gonna work? And don't forget our full stop. Submit. Didn't work. Oh wait, it's still busy. Okay, so we got an error. Yeah, so the percentage, let's just try percentage D and then take it from there. Is it supposed to be dot if? Percentage if. Submit. List object is not callable. Am I supposed to use square bracket? But I would imagine then the code's going to get confused because it's going to think I'm, I don't know, making a new list. I can't remember from yesterday how we called. I'm also going to change that to D, and if it doesn't give me decimals, it's getting weird. A number is required, not a string. If I take that out, because it seems to me like that's the only error that I'm getting, we can then work with not all arguments converted during string formatting. Not all O, because I've got a third. And remember, this is what it's telling us. So it says, not all arguments converted during string formatting. It's referring to our tuple because it's picking up, because I've only put tuple, I've got three things going on. So we need to put another percentage S. And now let's see. Your current balance is. This is amazing. So the problem now that we're having is with our number. So we have successfully managed from a list. I think it's what we call in Java indexing, to call on from a list to identify what position, like the 0 or the 1, that we want to call from our list. So I changed it to a list because it was confusing. I don't know why they had it in round brackets, because it's basically a list. It's separated by commas. So I've managed to do that. Now it's giving me an error when I try and call the number. Or we can say .2f. .2f. Don't forget our dollar. I also don't want to change too much, because then we don't know what our errors are. I forgot to add it in the tuple. I see we got disconnected. I have recognized that we have two decimal places, so I put .2f. Let's just try with .f, and hopefully it will give us all our decimal places. No, no, it's not. Floating point numbers. I don't put a dot. Yeah. So it has worked now because it bugs me. Like, what if you don't know how many decimals your thing will have? I don't like fixing it. But now that I remembered that if you just put the F without a dot and it will add zeros. That is not what we want. So I've replaced it. I've put the dot to F back. I've put a full stop to end my sentence and the dollar sign to obviously have the dollar in front of my value. I can see what the solution is and how I've overcomplicated it. It says here, hello, percentages. I've done that. Your current balance is dollar percentage S. So we don't even have to worry that this is a number and not a string. We'll try that now. Hello, John Doe. Your current balance is $53.44. Hello. So you will need to write a format string which prints out the data using the following syntax. And basically, although it's not recognizing that we've completed the answer correctly, as you can see, we have, and that means we understand or we know at least how to get the solution. Coding. So I'm just going to change it to percentage S because I think that's how they want it to be correct. If I say submit, hmm, yeah, so it works either way. I'm not going to worry too much about the percentage S and the percentage D when we're getting the right results. Let's take a look at the solution. So data equals, they've kept the round bracket. Format string equals hello, percentage S. We did that. Your current balance is percentage S. Format string percentage data. So what they've done here in a very fancy way, remember we had our tuple here. So I put the percent and then I put the tuple. So I converted this into a list, and then within my tuple, I called items from the list. What this is telling us we can do, important for being able to read the code, is what we do is we say, we're going to print format string, right? But now we haven't defined our tuple. But actually, we have defined our tuple up here in data. So that's where the percent data came from. I think I deleted the D by accident and I was calling it eta. I was like, what is that? Okay, so percentage data, and then it then picks up because of the percentage that the whatever is contained in here is our tuple. So you can actually define your tuple outside of the string or this line of code, if that makes sense. So you can define it beforehand, and then when you call on your string or you want to print it, you just put your percent and the name of your variable where you defined your data. I hope that makes sense. So, and then remember it calls on it in order. So the first line or the first elements in our data list, right, is John. So it's going to call on John first, then it's going to call on Doe, and then it's going to call on where the next percentage sign is the 53.44. So if we say submit, got to the same result. Obviously, probably that code, the way it's done here in the example, is cleaner. I think mine had a lot more writing, or it was more confusing to read, right? Because it had the square brackets and the 0 and the 1. And if you're trying to read that, like, it's going to be difficult to understand. So this is a cleaner, more precise way of writing the code by actually defining the tuple beforehand, and then you just call on it when you're ready to. That makes a lot of sense. So I think, guys, we can see that as we getting along with these basics, they taking much longer. I'd like to do a summary of what we've covered, and then we'll be taking another break. I'm really super excited about the hexadecimals. I can't wait to get more into it. Let's move over to our quick summary of string formatting. So I'm going to switch screens. Okay. So I'm just going to head over to ChatGPT, which actually summarized it quite nicely for us. Remember, we have learned that Python uses C-style formatting to create new formatted strings, so we use the percentage operator. So actually, on that note, remember where before we had to concatenate strings using the pluses, and we had to account for spaces with like this random empty inverted comma line. Well, now we don't have to do that, because now using the percentage, what do they call it? I need to get the jargon right. The percentage operator, we can actually format strings without having to do that. In other words, what we do is we create. So remember, for purposes of writing clean code, we can actually define it before our string. We can have items in here. Then what we do is we have our string. Now you can type everything exactly as you want it. You don't have to worry about spaces and all of those other things like hello. And then you just put in, then depending on what the type of data we're using, we've got the percentage S, and we've got, I'm going to put 2, percentage D. So do you see how impractical this actually is? In terms of writing your code, this makes life much easier, and it's definitely worth getting comfortable writing like this. Don't forget that now all we do is at the end we put our percentage after our string where we've got our spaces, okay, and then we put our percentage, and then you put in your tuple. So if it's one item, you just put in your tuple. If it's more than one, you put in your brackets, and then you separate it by commas in order. All right. And lastly, or you can just say percentage, and then you put it in your tuple, whatever you've named your tuple, which is this over here. as we saw in our example. So I'm just going to go menu, new. So we've got %s, which is used to format strings. We've got %d, which is used to format integers. So %s is for strings. %d is for integers. I think I've realized now, when I was getting that error on that exercise, I was using %d, and the problem was that particular number, which was 53,44, was not an integer in the strict sense of the word because it had a decimal. So that's why in the end we ended up using %f, which is, I'll tell you now, is for floating point numbers. So whenever you've got a decimal, so just for purposes of space, I'm not going to write the full thing. I'm just going to say decimals. And then what you can actually do here is actually specify if you wanted to round up to 2 decimal places, you say .2f, or you can say 1f, or you can just say f, but then it could add on like 3 extra zeros to your number. So I'm just making sure I've covered everything. Just the last thing is, and the most important for purposes of this channel, is the hexadecimals. So this will represent it in lowercase, and this will be in uppercase. It looks like it converts numbers to letters, and we're using base 16. I have no idea what these mean. So we are definitely going into more detail into that a bit later on today. I want to get some resources together first. Okie dokie, let's take a short break, guys. I want to grab some coffee and something to eat quickly. It will be about 10 minutes. And let's just see here. We will be learning next in our next tutorial. I see we're buffering quite a bit. Right, so in our next tutorial, we'll be doing basic string operations. Seems like there's quite a bit here on strings. So we've learned about our operators. We've done string formatting. Now my apologies, I switched over and the music was playing. I will see you guys in 10 minutes. All right, so to finish off this session, we're going to be looking at basic string operations. So remember, we've done our basic operators, we've done string formatting, and now it looks like we focused quite a bit on strings today. Now we're going to look at string operations. Strings are bits of text. I'm sure we figured that out by now. They can be defined as anything between quotes. So remember, this is my other kid. This is Bagheera. Remember, we can define strings with double quotes or single quotes. We also said in our first lesson that we were going to avoid using single quotes because what happens is we say a string 3, if we say, what should we say? I don't know. Don't. Oh, we're using single quotes. If we say don't, remember it's got an apostrophe. So we put in the apostrophe, and now all of a sudden it's limited the string to DON. So we're going to use double quotes to avoid that from happening. So let's just run it. Seriously? You can't sit on my keyboard. It would be funny if it was on. Come on. Oh, it's not doing anything because we haven't printed it. So say print a string, and you can put a comma. For example, to assign the string in these bracket single quotes, you need to use double quotes only like this. That is a terrible sentence, the way that was done. So we've got hello world in double quotes, print single quotes are, yeah, okay, print. So the length, I think Ali Ing gives us the length. So single quotes are, and then it tells us 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it counts the space. So it's counted all the letters in here, including the space. And that gives us the length of a string. This over here is 12. Single quotes are, and then it's printed that. And then it's also printed the length of the string. So I think that's pretty straightforward. That prints out 12 because hello world is 12 characters long, including punctuation and spaces. Great, I was waiting for this bit to get to the index. So I think what this dot index does is it tells us the letter O. We know that this is, let me just check my connection. Yeah, there is a bit of buffering. So we know that hello world, of course, I see we're getting disconnected. Remember, we always, when we're working with indexes, whether it's a list or like in this case, we're trying to identify what number, right? We always start with 0. So it will be 0, 1, 2, 3, 4. I'm curious to see if we say +1. Do you think it'll give us 5? No. No matter. Let's see what the exclamation mark is. So that would be 12, right? Right, so now we're not looking at index. So we've got len, we got index. Now we've got count, and it's going to count L. I'm not sure what that is going to do, what the count is. Maybe it doesn't include the zeros. Or it's going to tell us how many L's. Yeah, there we go. So there's 3 L's in the sentence. That is correct. I will do a summary of all of these. For those of you using silly fonts, that is a lowercase l, not a number 1. This counts the number of L's in the string. Therefore, it should print 3. Now we've got a string equals hello world. Print a string. It looks like we've made a list. 3:7. It's slow. Come on. O, and then 0, 1, 2, 3, 4, 5. Did I start with the 0? 1, 2, 3, 4, 5, 6, 7. Yeah, that's a little bit confusing. So now it's not using starting from 0. Because over here we've got L, O, and we've got W. So let's see what the explanation says. This prints a slice of the string. 3, 4, 5. 1, 2, 3. Yeah, I'm not getting it. Starting at index 3 and ending at index 7, at index 6. But why 6, not 7? Again, most programming languages do this. It makes doing math inside these brackets easier. So keep in mind, the maths is very important for programming Bitcoin. So these are things we need to remember and keep in mind. If you just have one number in the brackets, it will give you the single character at that index. If you leave out the first number but keep the colon, it will give you a slice from the start to the left end. If you leave out the second number, it will give you a slice from the first number to the end. You can even put negative numbers inside the brackets. They are an easy way of starting at the end of the string instead of the beginning. This way, -3 means third character from the end. So should we experiment with that a little bit? So it looks like we're not actually creating a list. What we're doing is we're creating a range. So from index 3 through to 6, because remember we're not including number 7, what they say, it prints a slice of the string. So that colon is important, and also note that we use square brackets. So let's just test it again. So if we start counting from 0, 0, 1, 2, 3. We get to the last L in hello. So 3, 4, 5, 6. I think I forgot the space. So 3, 4, 5, 6. Okay, that's why it looks like that. Just the LO. The space also counts as an index, and then the W. If you have just one number in the brackets, it will give you the single character at that index. So we did that up here. No. Yeah, here we identified what number of the index it was at. Now we kind of doing the reverse. We're saying start from, do number 3. Tell me what index 3 is in the string. It is L, as we know. And then if we do what they say here, which is just put a colon but no number after that, it should give us everything after. So low world. You can even put negative numbers. So let's try -3. So it's counting backwards. So 0, 1, 2, 3. Third character from the end. -3 means third character from the end. Well, that would be here. But it's only printing. Oh, okay. I thought it would slice that way, but it's just slicing that way. It's just a different way of doing it, I suppose. So instead of saying do everything from, if this is 12, doing everything from 9, we can say do it from -3. We get the same result. So you can put 9, so it's going to print everything from 9, or you can say -3, print everything -3 of 12, and we get the same result. And remember, it's slices of the string. A string equals hello world. Print a string 3 to 7 to 2. So let's run it. So it's only given us L. This prints the characters of string from 3 to 7, skipping 1 character. This is extended slice syntax. The general form is start, lost there, start at 3. You know that that's there. This prints the characters of the string from 3 to 7. Remember, it should stop there because it doesn't include 7. Skipping 1 character. I don't understand. ChatGPT. I don't understand this explanation. Sure, let's break down the Python slicing syntax and the specific example you provided. In Python, slicing allows you to extract a part of a sequence, such as a string, list, or tuple. So remember our tuples. The general form of slicing is sequence, start, stop, step, where. Start is the index where the slide starts. I get that, and it's inclusive. Stop is the index where the slice ends, exclusive. Step determines the stride, how many elements to skip. That is such a better explanation. So, if we go back to our first example, oh, I've now changed it, but it was 3, 7. This is our start, which is inclusive of index 3, which is L. And remember, it stopped at 6. It doesn't include a 7, so it's spelled out low. So let's just see if we can run that. Restart, run, low. So there's our start and our stop. And remember, the stop is exclusive. Step determines the stride, how many elements to skip. So it looks like over here we are saying start at 3, stop at 6, but skip 2. So where we previously had LO space L, we're going to skip 2. We're going to skip L and O. It looks like it skips backwards, or it steps. The word step, yeah, it steps backwards 2. Just see. So if we were here 1, 2, no, I still don't get it. If it's exclusive, 1, 2. Looks like it's also exclusive. Oh my goodness. Example breakdown. Given the string A string equals hello world, let's analyze the slice. A string, start 3, stop 7, step 2. The string A string equals step 2. The slice includes every second character from the start index up to, but not including, the stop index. It includes every second character. Oh, up to, but not including. Up to, but not including. So think of it as taking 2 steps. So, and we are up to, but so remember we are stopping at 6, which is this W here. So 2 steps is 1, 2. I still don't get it. 1. Yeah, okay, now I get it. Because you're not including the step number 6, which is the W. And then you're taking, but still 2 steps. It gives you L. Fine. Okay. The slice includes every second character from the start index, but not including the stop. What I also don't understand is the start index is L. We're starting at 3, 1, 2. So shouldn't it just be blank? Start at index 3, which is L. Skip 1 character to index 5, O. Index 7 is the stop index and is not included in the result. So the slice extracts characters at indices 3 and 5, skipping the characters in between, resulting in the string LO. So you should be getting LO, not L, according to ChatGPT. According to Python 3, the output is L. Yeah, I think there's a problem because according to ChatGPT, the answer's LO, even on Python 3. Says the expected output should be LO. So anyway, if we try and understand this from a ChatGPT perspective, because to be honest, I'm not understanding how it's just L, and it's too much inclusive, exclusive. So it looks like you have your start, you have a stop, and you have a step. It looks like you do your start, you do your step, and then your stop is just a reference. In other words, where you will not include or go further. So following it from left to right is not going to work. You do your start and then you do your step. So maybe I should pull up my notes here. Switch over. So remember, I think just to make this simpler to understand, I quite like the way ChatGPT kind of illustrates it. So we have our index, and it goes 1, 2, sorry, oh, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, we know it goes up to 11 because of the index starting at 0. Then we have hello, give a space, world, and then there's an exclamation mark, right? Good. Now the question is, we are trying to say print a string, and then in brackets we are saying start index 3, stop at 7, which means 6, and take 2 steps. So remember what I was saying was we do the step. This is just a reference, 7. So if we start at 3, we've got L. If we take 2 steps, we have the O and the space and the W. Now it's saying we're going to 1, 2, 1, 2. Let's just go to the ChatGPT explanation. So we start at L, move 2 steps forward to index 5. We can also do it as a simple math. So if we had 3 and we add 2, we're going to stop here at the space. Now it makes sense. So actually, when you're doing this type of slicing, think of it in terms of numbers. So starting at 3, we're taking 2 steps. So what's 3 plus 2? It's 5. What's at 5? Nothing. It's just a space. Index 7 is the stop index and is not included in the result. So remember, we've got 6, which is W, right? We're not going to include O because that's 7. And then I just want to, the slice includes every second character from the start index up to, but not including the stop index. So we don't, because we can't take any further steps, we can only take 1 step, not 2. The end result is low. If it was, say, index 8, right, which is R, and we did the same thing, so we said 3, we're going to say 9, which means we're stopping at 8. We say take 2 steps. Then we would end up with L, O, W, O. That's my understanding. Let's check with chat. So it said a string. What did I have it as? 392. 392 would the end result be LO W O. Let's see if I understand it. That means we've got it. We get it. So, moving on. So we understand start, stop, step. So in this next example, we wanted to take one step. So we're still stopping at 6, which is W. And we're carrying from 3, so it should say low. Yeah. Note that both of them produce same output. There's no function like strev in C to reverse a string. But with the above mentioned type of slice syntax, you can easily reverse a string. We're doing it backwards. Okay. So I'm not happy with, what are we going to expect us to do? To memorize this. Can you the logic in this code using, and I see there's a start, stop, step to reverse a string. Python, I might be repeating, but I think it's going to help us understand. Slicing a sequence, like a string, list, or tuple, is done using the sequence, start, stop, step. So we know that we use square brackets for creating lists, but we can also use square brackets for slicing strings. To reverse a string, you use the slicing syntax with the negative step value. That's the negative, I get that. The step value determines the direction and the interval of the slice. So the negative means, I suppose, that you're going backwards. The interval is how many steps you're taking. So in this case, because we're quoting the string word by word letter by letter in reverse, obviously it would be -1. A negative step means you move backwards through the sequence. So if we use the string hello world, here's how the slicing works. Start, when omitted, it defaults to the start of the string. Stop, when omitted, defaults to the end of the string. That makes sense, start and stop. So it just goes into default mode. And then step means that we take elements in reverse order. The step -1 means we start from the end and move backwards by one character at a time. Since the start is omitted, it defaults to the end of the string due to the negative step. Since the stop is omitted, it defaults to the beginning of the string due to the negative step. This effectively iterates over the string from the last character to the first character. That makes sense. I'm happy with that. Recap. A string, so colon, -1 in brackets, uses the default start and stop values, iterating from the end of the string to the beginning of the string. Why? Because of the negative, which determines the direction. So the -1 step means it moves to the top here. Let me just find it. Oops, sorry. So if we leave that empty, remember it printed everything from 3, which was this line of code here, hello world. There we go. Now we can also format, string operations. So we are also, it looks like we can change the case from upper to lowercase. That seems pretty straightforward. So string.upper gave us hello world all in uppercase, and a string.lower gave it to us all in lowercase. I'm curious to see, I say brackets because I see the brackets are empty, if it will, what will happen if it will just put the third letter in uppercase. just seems to be a bit stuck. Okay, I think that relates to the previous question or example. This is used to determine whether the string starts with something or ends with something, respectively. The first one will print true as the string starts with hello. The second one will print false as the string certainly does not end with ASD, FASD, and so on. So this is actually what we call a Boolean. Booleans return true or negative false values, and then we can use those values, true or false, to actually make decisions with our code. So this is great that we're having our first experience with Booleans. So a string starts with hello is true. A string ends with is false. If I change this to lowercase, I wonder if it will print false. If I change the H, yeah, it's false. So it's what we call a strict operator or a strict equality operator. In other words, it has to match exactly. So we must, if a string starts with a capital H, when you use your starts with and then in brackets, it must also start with a capital H if you want it to be true. So this code, this over here, it splits the string into a bunch of strings grouped together in a list. Since this example splits at a space, the first item in the list will be hello, and the second will be world. A string splits. Because I'm not printing. Print a few words. Run. Hello world. So split. So that's a useful, I don't know if function's the right thing to call it. Anyway, I'm going to make a summary of these tools that we are learning, these functions, whatever they're called. Exercise. Try to fix the code to print out the correct information by changing the string. Okay. S equals. Hey there, what should the string be? Hashtag length should be 20. Print length of S equals D, right? And then we've got our, what is it called? Tuple. I wanted to call it loophole. Our tuple. So our tuple is S, and we want to calculate the length of the string. So that is len. If we go to the top here, that is correct. It's len, round brackets. So that seems right to me. First occurrence of A should be at index 8, print. The first occurrence of the letter A equals, and you'll be using percentage %D because it's a number. Now, to get the percentage D, we're going to use our index. Remember, when we want to find out the index, we just say S dot index and then A, the first occurrence of the letter A. That looks right to me. First occurrence of letter of A should be at index 8. Number of A's should be 2. I just want to make sure that they use the index correctly. Yeah, it's inverted commas. I'm happy with that. Print A occurs again, percentage D, because it's a number, times. And then our tuple is S dot count, the number of A's. Slicing the string into bits. Print the first 5 characters are start to 5. The first 5 characters are different from indexes, aren't they? Because characters you're going to start you're not going to start at 0. So I think we're going to stop at 6. Okay. And remember, we've left the start blank so that it defaults to the beginning. Then we need to print the next 5 characters are percentage S. The percentage is the next 5 characters. So we're going to start at 5, that's correct. And 5 to 10. So we would stop at 11. If we want to go 5 to 10, print. The 13th character is percentage S. So percentage S is just number 12. The 13th character is, I'm already getting confused. I would say 13, not 12. Would it be 14? We'll see. Just number 12. The 13th, just number 12. The 13th here. Print. The characters with odd index are that makes sense because it basically wants the odd numbers, right? So we would start at it's inclusive. Yeah, so we would start at 1 and then we are taking steps of 2 and we're not stopping. That seems right to me. The last 5 characters are, this doesn't look right to me. Actually, I think it is. That's from last to end. Convert everything to uppercase. String in uppercase, percentage S. So our tuple is S dot upper. Everything to lower, S dot lower. check how a string starts. If S starts with str, print, that's fine. If S ends with ome, print, good. Split the string into 3 separate strings, each containing only a word. So we would say S dot splits. I just want to go back to our splits. Oh, yeah. So the split works because we've got a space here. So it will split. Every time there's a space, it'll split it into different words. Make sure you change the string assigned to S to match the exercise instructions. Try to fix the code to print out the correct information by changing the string. Length should be 20. So at the moment the length is 38, so we need to take away 18 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I don't suppose it needs to make sense, right? Okay. It says make sure you change the string assigned to S to match the exercise instructions. Length should be 20. The length is 20. First occurrence of A should be at index 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Hey, Vera. Oh my goodness. This is a silly exercise. The first of occurrence of letter, so it's still not matching the instructions, is 8. Number of A should be 2. That is correct. A occurs 2 times. Citing the string into bits. The first 5 characters are 1, 2, 3, 4, 5. Yeah, so I got muddled up. So if I make it 5, not 6. Submit. 1, 2, 3, 4, 5. The next 5 characters are, I would say, I still think it's 6 start to 5, but anyway, I suppose the space is a character. The next 5 characters are, and I need to make it 5 to 10, but remember it includes 5. But I want to start with H, and I think that's correct because we're stopping at 10, but we must make it 11 because it's exclusive. 1, 2, 3, 4, 5, 6. It's counted 6, not 5. 5, 6, 7, 10. Okay. Suppose it's 10. The 13th character is I have to do this a dumb way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Should be W. Yeah, I got T. So just the number 12. Okay. Odd index EHR 0, 1, 2, 1, 2, 4, 5. So the next one is H and 3 L. Okay. The last 5 characters are 1, 2, 3, 5. That looks right. String in uppercase, that worked. String in lowercase, that worked. And that seemed to work too. The splitting of it, because we said split and then we put a space. Let's see. Oh, I don't quite get it. Let's see the solution. Strings are awesome. Let's see what the answers are. Okay, length of S is 20, A is 8, A occurs 2 times. I got that right. The first 5 letters up to 5. Yeah, okay. 1, 2, 3, 5. So it's strip. Yeah, that makes sense. So it's yeah. So we would say, so we leave it blank there because it defaults to the beginning and then we stop at 5. Print. The next 5 characters are, and he wanted us to go 5 to 10, so that was quite simple. 5 to 10. So you know what? I'm honestly not understanding because the next character, right, is now we went up to 5 and then we're starting at 5. So I think that demonstrates how like your exclusive, which was here, we can't see it here, was 5. It still gave us 5 characters. Okay, but here it's inclusive. So here it's safe to say 5. Even though the 5's not there, it's because 5 is exclusive here. Then we want to print the 13th character. So it would be -1 because, so it would be, we would put in 12. So 13 minus 1 because the indexing starts at 0. Then this was correct because we're going to, when it came to doing the odd numbers, we start at 1 because 1 is not even, and then we take steps of 2 because every 2 steps, 1 plus 2 is 3, that's an odd number. And then there's nothing in the middle in the stop because we're evaluating the whole string, so we're not stopping any. The upper and the lower is fairly simple. Remember, we've defined our, what's it? Our, something with a T, our word tuple over there. Starts with, that's also fairly simple. Remember to use your uppercase when needed, otherwise it will return a false. The reason why it's printing is because it's true. So that's something we'll learn with Booleans. If S starts with str with the capital, sorry, in uppercase S, then it will print the string, which is what it did. If I change that to lowercase, it won't print the string. And then it's the same with the ending. Then it prints string ends with me. Good. String ends with OME. That's because our Boolean was true. And then lastly, to split it, that was quite simple. Just remember you use dot split, and then we're splitting it every time there's a space, so we get all the words. I just want to test that where we get a false value. Now it's not giving me an error. Seems to be working. Okay. So I don't know, I can try and submit it again, but it looks like it's working. So it's not giving an error. Yeah. Okay, we'll clarify that as we go along with it. Is a strict equality operator or not? Maybe it's because there's no else statement. Or maybe it's not even really a Boolean. I could be mistaken. Like a Boolean in the true sense of the word. Shall we do a quick summary? I see the stream, yeah, it's already been 3.5 hours. Let's do our summary. So we learned, you might want to take notes of this. We're getting into like a lot of tools here in Python where we're going to have to, I guess, sort of memorize these things if we ever want to use it. So we know that strings are bits of text. We know that we use the double quotations, not the single, because we want to avoid problems in our string. Then we learned, one of the first things we learned was about the length. So let's say we've defined a string and we put a jumble of letters in there. I'm just going to put bracket. It gives us the length of the string, okay? Just want to see here. And the way it counts the length is it uses all the characters, and that includes spaces. So that is len, L-E-N. Then we can check using index. So it would look like this. If we had a string and we wanted to check what number on the index is G, we would say dot index, and then in brackets we would put G, because we're trying to find out what index is G, keeping in mind that now we start counting from 0 when we count the index. Now we learn slicing of a string, and that's quite simple. So in the context of today, we learned, for example, we want to print a string, but we're going to slice it. So then we have our x, I'm just going to say x, y, z. We have our start, our stop, and our step. So this is what we call a sequence for splitting. So this tells you where we're going to start, and it's inclusive. Then we look, if there's nothing here on the start, it will by default start at the beginning. Okay. Then if there is a third value, in other words, a step, we go straight to the step and we see how many steps are we going to take. For example, if we're trying to just pull out a list of even numbers or odd numbers, it would be 2. And then we would obviously start on an even number here if we're looking for steps of even numbers, or an odd number if we're looking at steps in odd numbers. And then we would then take our steps from our start, but not including, so it excludes where we stop. So if this is blank, it will basically do the step on the whole string. Otherwise, we can quite simply define it. And remember, if we don't define, I've basically just said, if we don't define the stop, then it's basically infinite. Then also remember, we learned that we can work backwards. So a positive is obviously left to right, but if you want to reverse a string, you put a negative, then that tells Python we're going to be working in which direction? We're going to work backwards. And you can say -1, you can say -2. Okay, and remember, if you don't define your start, because now you've chosen to work backwards, it will by default start from the end and work backwards. Let's just see what else. So also another thing on indexing is we can choose to slice anything, say from, we just say 3, then it will slice everything from 3 onwards. Okay. So by the way, if you're interested, this is called extended slice syntax. I have run out of space, so I'm just going to quickly do a new one. Before I do that, we've got len, we've got index, the next thing is we learned, for example, we can say if we want to convert our text all to lowercase, yeah, so it's just dot upper. And then we have a string dot starts with, and then in brackets you can put whatever your requirements are, or you can do the same thing but ends with. And then based on that, you can tell Java what needs to happen next. Lastly, I can fit it in here. We've got the split function. So we can take a string, right? We can say dot split, and then in the brackets we define how we split it. So in the examples we did, because we were writing sentences, we wanted to split each of the individual words. So we just put in an empty space here so that Java knows when it prints the new list. So you would just say print here. It's going to know that it has to split the words according to the spacing. And in that way, we were able to take a sentence and split it up into individual words or individual separate strings instead of one string. Okie dokie. So guys, that was a lot of fun. I think we made a lot of progress today. I'm very excited about what was it called? The hexadecimals. So right now we are going to stop this live. Thank you for joining and for watching. I'm now going to pull out some resources so that we can get digging into hexadecimals and how it works within Bitcoin. Super excited. This is what I wanted and this is what I'm looking for while we on this journey of learning programming Bitcoin and learning Bitcoin from scratch. I will, with each of these lives, be breaking them down or into new videos of shorter segments. So that should make it easier to follow along in your own time. So you can expect yesterday's live to be uploaded. And yeah, I do apologize for the buffering. I hope it's not too much of an issue. That will be sorted out in due course. And if there's any questions, yeah, just ask in the comments. And yeah, I will see you guys soon because next we're going to be doing hexadecimals. Awesome. And don't forget to practice. Practice your coding.